The universe operates on an incomprehensible scale of energy. Entire galactic clusters burn with the power of trillions of stars. Down here, our footprint on this fragile curve is incredibly small. Right now, humanity consumes about 10 to the 13th power watts of energy each year. We generate almost all of that by scraping the Earth's crust, burning fossil fuels, and splitting heavy atoms through nuclear fission. To measure how intelligent life develops, astrophysicists use the Kardashev scale. This diagram maps a civilization's advancement based on its total energy consumption. As you can see, that marker lands exactly at 0.73. We haven't reached Type 1. We are a Type 0 civilization. Before we can climb that scale, we face a barrier known as the Great Filter. This is a severe evolutionary bottleneck, where a species acquires the technological capacity to destroy itself through nuclear weapons or climate change, long before it has the wisdom or resources to leave its home world. If we trigger our own extinction, the journey ends right here. Passing through this filter of self-destruction is the absolute mandatory requirement before we can even begin to think about interstellar travel. To cross the threshold into a Type 1 civilization, we need to drastically increase our power output. We must reach 10 to the 16th power watts, which requires harnessing 100% of the solar radiation that actually reaches our planet. While expansive wind and solar farms are excellent stepping stones, their yields cap out. They simply cannot push an entire global society across the Type 1 finish line on their own. The required leap in energy demands a specific breakthrough in physics, the mastery of nuclear fusion. Unlike our current fission reactors, which split heavy atoms and leave behind dangerous radioactive waste, fusion forces light atoms together. It mimics the core of the sun, yielding massive amounts of clean, stable power from abundant elements. With limitless, clean energy at our disposal, resource scarcity becomes a thing of the past. We gain the power to perfectly stabilize our global climate, eliminate major diseases, and construct permanent cities deep beneath the ocean's surface. By commanding the total resources of our home world, we transition from vulnerable inhabitants at the mercy of natural disasters to the absolute masters of Earth. According to some estimates, we could hit that Type 1 milestone in a few centuries. Fast forward roughly 3,200 years, and humanity's continued growth will hit a strict physical wall. The energy of a single planet will no longer be enough. This chart visualizes the next requirement. To reach a Type 2 civilization, we must execute an exponential climb, multiplying our power output 10 billion times to reach 10 to the 26th power watts. To hit that number, we have to capture the entire energy output of our sun. We achieve this by constructing a Dyson swarm. This is a massive, decentralized web of solar collectors designed to orbit the star and wirelessly beam its raw power directly back to our civilization. Building something this colossal requires unimaginable raw materials. We would literally have to dismantle unusable planets and dead asteroids, re-engineering their mass into a dense swarm that eventually covers the star entirely, obscuring its light from the rest of the galaxy. A star's total output sustains anti-gravity engines for extended travel and fuels the biological regeneration needed for near immortality. With that level of medical and technological dominance, no asteroid impact, pandemic, or local solar system event could wipe us out. We become functionally invincible in our corner of space. Give it another 5,800 years. Our species spreads, our demands compound, and eventually the total output of a single star becomes a limiting fraction of what we need. To hit the Type 3 threshold, we must secure an incomprehensible 10 to the 36th power watts of energy. You can no longer look at individual stars. You have to treat an entire galaxy as a single, connected power grid. We move beyond standard stellar energy and tap into extreme physics. We start siphoning photons directly from the superheated accretion disks spinning around the supermassive black holes at the galactic core. Traditional spacecraft become obsolete. With this volume of energy, we bend space-time itself, opening wormholes that allow instant travel from one edge of the Milky Way to the other. To survive these physical extremes, our biology has to evolve. We likely abandon our fragile organic bodies entirely, merging with advanced robotics or digitizing our consciousness into pure, transferable data. A Type 3 civilization treats the galaxy as an engineering project, manipulating its structure and mechanics on a total scale to suit its needs. Theoretical physics suggests the scale extends even further. Types 4, 5, and 6 describe entities capable of harvesting the energy of supernovae, manipulating dark energy, or traversing higher spatial dimensions beyond our physical reality. But when you compare that godlike scale to where we currently sit, the chasm looks almost impossible to cross. The Kardashev scale is a literal roadmap for survival, defining the energy thresholds required to outlast planetary limits. To ever reach those galactic heights, we have to deal with the immediate hurdle right outside our window. Everything, our expansion, our mastery of physics, our ultimate destiny among the stars, hinges entirely on whether we can figure out how to graduate from a Type 0 civilization without destroying ourselves first.